Students, in this lecture we are going to discuss the new module, that is multiple integral 2. In that our first topic is change to polar. That means here we have to change our Cartesian coordinate xy into the polar coordinate r and theta. So for this there is a standard substitution, that is we have to replace there x by r cos theta, y by r sin theta, and dx dy by r dr d theta. Now I am going to explain this topic using one example, and the example is evaluate by changing to polar coordinates double integral from 0 to 1 and x to square root of 2x minus x square plus y square dy into dx. First of all, we are writing this double integral in details. So for this we can observe that this inside integral, upper limit and lower limit of this inside integral both are the function of x, and therefore for this integral our y is varying. That is why we can write this integral as y equals to x to y equals to square root of 2x minus x square, and remaining integral is from 0 to 1, so this integral I can write as x equals to 0 to x equals to 1. For this inside integral our y is varying, so that we are taking this integration with respect to y, and outside integral with respect to x. Now from the upper limits and lower limit of both the integral we can write the region of integration. Therefore the region of integration is bounded by y equals to x, y equals to square root of 2x minus x square, x equals to 0 and x equals to 1. And these all curves are nothing but the upper limit and lower limit of this both integral. So in that curves you can observe that your first curve is y equals to x, that is equation of line passing through origin. Second curve, that is y equals to square root of 2x minus x square. If we simplify it, we will get y square minus x square minus 2x equals to 0. That means we are taking square to both sides, and we are taking this RHS term to LHS side, and you will get this y square plus x square minus 2x equals to 0. Now we have to write this equation into the standard form, so that I am adjusting plus 1 at RHS side and plus 1 at LHS side. So if you take plus 1 at LHS side, we will get x square minus 2x plus 1, and this is nothing but the x minus 1 bracket square. Here RHS of 1 is as it is, so this equation I can write as x minus 1 bracket square plus y square equals to 1, and which is nothing but the standard equation of circle having center is 1 0 and radius is 1. Similarly the next curve is nothing but x equals to 0, which is nothing but whole y axis. Another curve is x equals to 1, which is the equation of line parallel to the y axis. Now first of all we are plotting all this curve on the graph. So if you plot all this curve on the graph, we will get this figure. So in that our first curve, that is y equals to x, is nothing but equation of line passing through origin, that is this line. Similarly second equation, that is y equals to square root of 2x minus x square, that is nothing but this circle having centered is 1 0 and radius is 1. So you can observe that this is the circle having centered is 1 0 and radius is 1. Similarly the next curve is x equals to 0, that is nothing but whole y axis. Similarly x equals to 1, that is nothing but the line which is parallel to y axis. Now we know that our y is moving from 0 to infinity, that is to the upper side, and x is moving from this 0 to infinity, that is this RHS side. And therefore according to our lower limits and upper limits we are getting this common region. So this region is our region of integration. Now our target is to change the Cartesian coordinate xy into the polar coordinate r and theta. So first of all we are writing all this equation into the r and theta. We know that in the beginning we have already discussed this substitution, that is we have to replace x by r cos theta, y by r sin theta, and dx dy by r dr theta. So using that substitution, if we put y equals to r sin theta and x equals to r cos theta, we will get this equation. So this equation if I simplify, then I will get sin theta upon cos theta equals to 1, and it will be the tan theta equals to 1. So automatically you will get theta equals to pi by 4, and which is nothing but the equation, that is y equals to x. Similarly if we change the next curve that is y square plus x square minus 2x equals to 0. So if I replace x by r cos theta and y by r sin theta, we will get r sin theta square plus r cos theta square minus 2r cos theta equals to 0. If we simplify it, we will get r square equals to 2r cos theta, and 1r will get cancelled. We'll get only r equals to 2 cos theta. Similarly, we can write this x equals to 0 as r cos theta equals to 0, and from that we can write theta equals to pi by 2. Now after changing the Cartesian coordinate, that is xy, into the polar coordinates r and theta, I am writing all these curves on the graph. So you can observe this second figure. This line is nothing but x equals to y, and this equation is theta equals to pi by 4. Similarly, we can write this equation of circle as r equals to 2 cos theta, that I have written here. And we know that on x-axis at RHS side your theta is 0. Similarly, on y-axis upward side your theta is pi by 2. On x-axis LHS side, that is theta equals to pi, and at lower side of y-axis theta is 3 pi by 2. Here we have to find the limit of integration in terms of r and theta. So for this, first of all, I am taking one strip that I have drawn in the shaded region. That is, you can observe this shaded strip. First of all, we know that r is the nothing but radius and theta is nothing but angle. So you can observe that your r is starting from this origin and ending at this curve, and the equation of curve is nothing but equation of circle, that is r equals to 2 cos theta. Therefore our r varies from r equals to 0 to r equals to 2 cos theta. Now we can observe that the angle between this line and this line, that is line y equals to x, is nothing but pi by 4. But our region of integration is this, and for this region of integration our theta is moving from this angle pi by 4 to this angle pi by 2. So our theta varies from theta equals to pi by 4 to theta equals to pi by 2. Now we got the limit of integration 4. Therefore we can write our given double integral as integral from 0 to 1 and x to square root of 2x minus x square plus y square dy into dx. That is our given integral. This integral I can write as inside integral r equals to 0 to r equals to 2 cos theta, and outside integral is from theta equals to pi by 4 to theta equals to pi by 2. Also we have to replace our whole Cartesian coordinates into the polar coordinate. So this x square plus y square I can write as r cos theta square plus r sin theta square r into dr d theta, and that we have taken from our standard substitution, that is x equals to r cos theta, y equals to r sin theta, and this dy dx, that is dx dy, replaced by r dr d theta. And if we simplify this term, we will get r cube. That means if you take a square of this term, that is r square into cos square theta, and this will be the r square into sin square theta. So from that both term we can take r squares common. So inside bracket we will get only cos square theta plus sin square theta, and the value of this is 1. So r square theta is remain only r square into this r, that will be r cube. Now we are finding one by one integral. So you can observe that here we have to take integration with respect to r. So the integration of r cube with respect to r is r raised to 4 upon 4, and the upper limit and lower limit are r equals to 2 cos theta and r equals to 0. That time our outside integral with respect to theta as it is. Now I am putting upper limit and lower limit. So if we put upper limit, we will get 2 cos theta raised to 4 upon 4 minus lower limit is r equals to 0, that is 0 raised to 4 upon 4. After simplifying it, we will get only 4 into cos raised to 4 theta, because here 2 raised to 4, that is 16 upon 4, there is only 4. So 4 cos raised to 4 theta only remains. Now I am taking this 4 to outside the integral, and I can write this cos raised to 4 as cos square its square. And we know the cos square theta formula, that is 1 plus cos 2 theta upon 2, bracket square as it is. I am splitting this first of all bracket square, and this bracket I can write as 1 plus 2 cos 2 theta plus cos square 2 theta d theta upon 4. Again I am not able to find the integration of this cos square 2 theta, so again I am taking this cos square 2 theta as 1 plus cos 4 theta upon 2. That means again I am using cos square theta formula. So after simplifying these terms, we will get 3 by 2 plus 2 cos 2 theta plus cos 4 theta upon 2. Now we can take the integration of this with respect to theta. So here 3 by 2 is constant, so integration of 1 is theta plus integration of cos 2 theta is sin 2 theta upon 2. Integration of cos 4 theta is sin 4 theta upon 4. So after putting upper limit and lower limit, we will get 3 by 2 into pi by 2 plus sin 2 pi by 2 plus sin 4 into pi by 2 upon 8, minus if we put lower limit, we will get 3 by 2 into pi by 4 plus sin 2 into pi by 4 plus sin 4 into pi by 4 upon 8. That means in the first bracket we are replacing our theta by pi by 2, and in the second bracket we are replacing our theta by pi by 4. So after simplifying all these things, we will get 3 pi by 4 plus 0 plus 0. 0 that means sin pi and sin 2 pi, minus 3 pi by 8, that is this term, plus 1. Here sin pi by 2 is there, that is why the sin pi by 2 is 1, and another that is sin pi, it will be 0. So after simplifying this, we will get 3 pi by 8 minus 1. That is our final answer. Thank you.